things like that. All right, let's get into it. So hi, everyone. I'm Matthew. I'm a studio intern, and I will be conducting today's tutorial on the Overworld for our Build an RPG series. Oops, sorry, that's too far. All right, so if you didn't already download the skeleton package, it is linked within the GitHub README link that I will be resending in the chat. And if you didn't already import it into your own Unity package, don't worry, we'll go over, or I'll go over how to do that. And then the repo is the same link. Right. And then our goals for today, just to get like a basic understanding of how to make and fill an area. So we've got like a sample NPC, a very rudimentary dialogue system. We'll be setting in different layers for grass encounters and another one for like collisions, things like that. You'll see as we go on. And, just follow along in the README. Everything should be there. I'll be going over it myself, but, just in case you missed something, it should be there as well. And don't hesitate to ask any questions, or if you're confused or anything like that. If, I can't help you if you don't let me know. All right. So let's get started. So from here in Unity. First, we're going to go to Assets, Import Package, Custom Package, and then from there, you'll be able to click the skeleton package and open it up. Once you're done, you should have something that looks just like what I have on my screen right here. And if anyone's having any difficulty with that, feel free to let me know. So once the skeleton package is open, we're going to start by just going over some of the initial things that are already included. So some of the objects that we already have here, we have our grids already, or our grid system already set up. So as you can see in your scene, there's already sort of a grid system in place. That'll just make it easier for us to place tiles, things like that. And then in that, you'll notice there's 3 tile maps, one for the background, one for solid objects, and one for tall grass. I just put this here already, so that way we don't have to go through the trouble of just creating that and all the potential mishaps that might ensue if we have like a slight name difference or a spacing difference or something like that. We also have the player object right here, just this red guy in the middle-ish part of your screen. And the scripts are already attached to it, but we will be filling those out. So right now it doesn't really do anything. To the red person's left, you'll see a blue person who looks very similar. And that is our NPC who already has their script attached, but we will also be filling that out. And last but not least, we have empty game object called Game Controller, and that's got our Dialog Manager script attached to it. All right. And now we're going to go over some of the scripts that already exist. So from here, we've got Interactables. So Interactable is an interface that just kind of forces anything that's connected to it to have some kind of interaction function. So although we only use this right now just for our NPC, hypothetically, if you were to expand on this and make some more NPCs or just kind of experiment with your own, you'd want to connect this to the interface Interactable. As you can see in the NPC Controller script, up at the top where it says public class NPC Controller, mono behavior, we've added comma interactable, and that's what's connecting it to the interactable interface. Another one of the scripts that we have already included is the dialog class. So this is just a list. A list, if you're unfamiliar, is just like a structure that's just a bunch of some type. In this case, is string. So this just exists if you wanted to try and implement multiple lines of dialogue. Just for today, for the sake of time, we're only going to be going over 1 line of dialogue. All right, so now we're going to get started on putting the work in. So first, we're going to put the layer in player and some other objects. So right now, our guys are just kind of floating in open space. So we're going to put in some background tiles to make it a bit more appealing. So if you click the background tile map over in the hierarchy For me, it's on the left, and it should be a child of grid. And then you want to go to window at the very top, right, where it says file, edit, assets, everything like that, window, 2D, and tile palette. And then that should open up a tile palette window. You can drag that to wherever you want. I have mine right next to the inspector, just so I can switch back and forth between the two pretty easily. All right, and there should already be an existing tile set called background tiles. And if there is not, just let me know in the chat. But otherwise, I'm going to assume that everyone's got it set up. All right, so just right now, you can click on one of the tiles that you'd like to be your background. So for me, I'm just going to use one of these grass ones here, and then I'm going to use the rectangle brush tool. You can click manually as well, but I'm just going to drag across. So you'll notice that now after you've dragged your background across, that it actually ends up covering our NPC and our player, which is not what we want. So first, we're going to go layers. There we go. Okay, so we're going to open sorting layers, and we're going to open layers. All right. So right now, we're going to add some sorting layers. The first one should be background. I'm just spelling that with a capital B and no spaces. The second one's going to be foreground, capital F, no spaces. And the last one is going to be layer. All right. Nick says, I downloaded and added the skeleton package, but I don't see everything. I only see combat scripts, scenes, and scripts folders. Okay, so there should be a file called Pokemon scenes. And then from there, you'll want to open the overworld scene from there. Nick, and if you're still having trouble with that afterwards, just send another message and then we'll try to figure it out. In the meantime, in our sorting layers, we'll have added background, foreground, and player, and that should be the order they're in from top to bottom. All right, and then now we're going to go to our player object in the hierarchy. We're going to scroll to the sprite renderer component in our inspector, and then we're going to set the sorting layer to player. And after doing that, you should have your red guy appear on screen in front of the background, right? And then we're going to do the exact same thing. We're going to go to our NPC. We're going to go to their sprite renderer and set that also on player because we want them to be visually on the same level as the player. And next, we're going to go to the background object in our hierarchy, which is the child of grid still. And in the tile map renderer, there should be an additional settings that should already be spread out. But if it isn't, just click the little triangle and it'll spread out. And we're going to set that layer to background. And just to get ahead of the curve, we'll go to the solid objects layer. And we'll set that as foreground. And for tall grass, we will also set that as foreground. So we haven't placed anything yet, so nothing should show up for the solid objects and tall grass layers, but we're just going to set those up now, so that way it benefits us in the future. All right. Now that that is done, we're going to start working on our layer. So I've got mine in now. It looks like the layer stuff got removed partially, or at least undone. So we'll just go over that again. All right, so now that we're here, let's click on our player in the inspector. And then we're gonna open edit layers and just kind of re-add the layers that we added before. So the first one being background, capital B, second one being foreground, capital F, and then the third one being player. All right. And then from here, we're going to go to our player object in the hierarchy. We're going to look at their sprite renderer and set their sorting layer to player. That should make them appear above your background. We're going to go to the NPC, do the same thing, set the sorting layer to player. And then last but not least, we're going to go to the children of our grid. And then so starting with the background tile map, we're going to go to the tile map renderer component within the inspector, and then change the sorting layer to background. Solid objects should be set to foreground, and tall grass should be set to foreground. And then once everyone's caught up to that point, if I could get like a check-in, so something, just a message in chat or like the little thumbs up reaction, that would be great. Sweet. All right, so now that we're caught up to where we were before, we're going to start with our player movement script. So as of right now, our player doesn't really do anything. Their movement script should already be attached, but very empty. So we're going to go to scripts, and we're going to just open the player movement script. So at the top, you'll notice that there's like private animator, and the awake function, which just sets the animator up. That's just included previously, so that way when we do get our player moving, they already have a bunch of animations set in place. So that way we can tell what direction they're facing, everything like that, just so it's easier than having one person just kind of like blop around on the screen. And as we get started, first we'll need to add some variables at the top just to keep track of things that we might want to change or anything like that, or just use in our functions. So first we've got public float move speed. And then for that, I've got move speed as one word, but then with a capital S on speed. Private bool is moving. And then we set that as private just, so we don't accidentally mess with it while we're playing the game. And then lastly, private vector2 input. And next, we need to make the move function so that way we have a way for our player to move. So within our move function, we've got two to-dos. So the first to-do being move to target position, which we're going to fill out right now, and another one for check for encounters, but we will get to that later. Right now, there should be a return null, but we'll remove that for right now. It was just included so that way in the event that like your Unity somehow crashed and you try to reopen the project, it wouldn't force you to enter in safe mode. All right. All right, so first, when we want to move our player, we're just going to set is moving to true. So that way, everything's aware that we are moving. And while the target position, actually, I'll just type this out real quick and then I'll explain everything afterwards, because explaining and typing is a little bit tricky for me. It did trail off a little bit. Okay, so now that I've typed everything out, so at the very beginning, we're going to set is moving to true. So that way Unity knows that we're moving and everything now. And then next, we have a while loop. So it just compares like where we want to go, the target position and the transform position. And then it just checks if it's greater than math f.epsilon, which is just like a really small value. So it's pretty much saying like, while you aren't where you want to be, move towards that position. And then at the end, we'll just set the transform position to target position because we've been moving towards it. And then eventually, we set it where we want it to be. And then we set is moving to false because we're no longer moving. All right. And then after that, now that we have like a method for our player to move, we need to actually have that player move. So now we move to the update function, which should be right above. and we're going to do the first to do within that section, which is taking input and setting up grid-based movement. So first, I'll just do the same thing before, type out the code, and then we'll kind of just talk through it. So we want to check if, we're not moving, then we'll take in input using get access raw. And then one of the useful things about get access raw is that the value will either be like 1 or -1. So that way, it just makes the math nicer. So then we check if our input, isn't nothing pretty much. And then we're just going to add in some lines right here for the animator. Don't worry about them too much, but I will explain what they do afterwards. All right, so what we have here for our update function, so we first check if we're not moving, and then if we're not moving, we'll take in the user's input. So their X input will be from the horizontal axis, and Y input is for the vertical axis. And then we check if our input overall isn't 0, then we set this right here for the animator lines. That's just letting the animator know like what direction the player is facing. So the first line, set float move X to input X, just lets the animator know if they're facing left or right. And then the second one lets the animator know if they're facing up or down. We will use the move X and move Y later for the NPC interactions because it's helpful. We want to make sure that the player is facing the NPC to interact with them, so they're just like facing the other way and somehow talking with the NPC. And then afterwards, we just make a target pause variable to grab where we're at currently, and then we add the player inputs to that, and then afterwards we move to that point. So by adding the player inputs to that, it just kind of moves our target pause to wherever they set their input to. And then from there, we're just going to add one more little detail. So right above the if statement, checking if input is not equal to vector2 0, we're just going to add another if statement. So we're going to say if input X is not equal to 0, we'll just set input dot y equal to 0. So this enforces our node like diagonal movement that you don't really see in Pokemon until generation 6, but we'll keep it to the simpler right now. All right, and then we'll just save that and we'll switch back to Unity. I'm getting an error. Oh, I see the issue. Okay, I forgot to capitalize the I on input.getAccessRaw. That's why I was getting an error. So the initial error is that because I was using the lowercase I, it was thinking that we were using our private vector2 and not the actual function to get input. That's my bad. All right, so now that we're here, we're going to save this again, and that should hopefully fix things. All right, I'm not having any error messages now, and then we'll just use this as like a quick check-in point. So if you hit play in your Unity window, you should be able to move the player around, or at least have them change directions. Oh, I know what the issue is now. I totally forgot to do this. I'm so sorry. In the player object in the hierarchy, we have to go to our player movement script and actually put in a movement speed. It was there initially for me, but now once that movement speed is not 0, your player should be able to move. Let's see. For right now, maybe we get back to that, and then we'll just move on to another topic. So worst case, if we can't figure out what the issue is here, then we still cover some. Oh, okay, it works now. That's great. Okay, sweet. So we're able to move everything now. All right. So now after we've implemented our player movement, since they can move around, we do need to start adding some things for them to essentially crash into or to block their path. So we're going to move on to collisions. Okay, so for collisions, we're going to go to the solid objects tile map within our hierarchy, which is underneath grid. And then we will open the tile palette again. So window 2D tile palette. And then for mine, I'll just drag that over there next to my inspector. And then you can set the palette that you're using to Overworld to grab some tiles that would seem like appropriate obstacles. So for right here, I'm just gonna drag a box around this house so I can place the house on our screen. And that will be my solid object for the sake of the tutorial. And it's already on the foreground, but we do need to add an actual user layer this time. So we go to layers, edit layers, and underneath sorting layers, there's just a layers category. So here, we're just gonna add solid objects. Another user layer we're gonna add is tall grass, which we will get to later. And the last one being interactable. So solid objects, tall grass, and interactable. I don't think the order matters too much, but if you're trying to just have the exact same things I do, I have solid objects, tall grass, and then interactable from top to bottom in that order. And then we're going to go to solid objects here, and then add the layer solid objects. So not the sorting layer, but the actual layer itself. So that should be in the top right portion of the inspector, right underneath the name of your object. Just say layer. All right, and then after that, we need to add some components. So first thing we're going to add is a tile map collider 2D. And next, we're going to add a composite collider 2D. When you add the composite collider 2D, it will also add a rigid body 2D. So if that shows up, don't worry, you're still doing everything right. So in our tile map collider 2D component, we're going to check used by composite, or sorry, composite, and that'll tie it to the composite collider 2D. For our rigid body, we're going to set that to static. If we left it as dynamic, then once we ran the scene, the house would just kind of fall out of it. And for our composite collider 2D, we're going to change the geometry type to polygons. So now you should have like a very thin green outline or green series of outlines around the whatever you placed. So I placed this house, and now there's kind of like a rough outline of that house that serves as a collider. All right. So as of right now, I believe the player should be able to walk through this, even though the collider exists. So we need to add a check for that in our player movement script, so that way it properly does not walk through a house. All right. So we're just going to go to our isWalkable function. There's a return false right here, but then again, that was just added so that way we can enter this without having to force safe mode, which Unity does whenever there's compiler errors in script. So the first thing we need to add is more variables at the top, just so that the script itself can keep track of the existing layers. So we have public, layer mask, and then I'm just going to name it solid objects, lowercase s, capital O, and then another one, public layer mask, grass layer, and then public layer mask, interactable. So those are just going to be the three layers that we're going to use. All right. And then now we scroll down to our isWalkable function. So this just exists so we can check if we can actually walk into the area that we want to go to. So we're just going to have an if statement, physics 2D dot overlap circle, capital O, capital C, and overlap circle. And then the parameters for that are target pause, a radius. So I'm just going to use 0.1 f. The f is there because it's a float. And then the solid objects layer. So whatever you named your solid objects layer before, that's what you should put as that parameter. Right. And then we check if that does not return null. So that means if we do come into contact with something that's on the solid objects layer, we're just gonna, for right now, we're just gonna hit debug.log, and then you should go a message like can't walk there, or something like that, just so we can keep track of whether or not we're able to walk there or not. And then otherwise, within the if statement, we also want to return false. So that way, we don't actually move there. And then last, we'll have a return true. And then back to our update function right here, we're gonna add an if is walkable. Oh, sorry, that's the wrong one. Ignore that bottom part. That was part of me troubleshooting. Okay. So as part of our start coroutine move, we're now going to surround that with an if statement. So underneath, if is walkable. Then we check if our target position is some place that we can actually walk. And then we'll place our move within that if statement. All right, and then after we save and go back to our Unity, we should have an obstacle that we cannot walk into. And if you want to have like the quote unquote like signature Pokemon like character placement, you want to check that your X value in your transform position is that something that ends in 0.5, and then your Y value is something that ends in 0.8. So that way you're just like a little bit above the center, like people normally are within Pokemon games. Okay, cool. So now we can move, but that's not good. Oh, I forgot to add the parameter again here. So remember in your player movement script, remember to go to solid objects layer and then actually set it to solid objects. And while you're at it, you can set the grass layer to solid grass and the interactable layer to interactable. But you only really need to set the solid objects layer to solid objects for right now. All right. And then if I could just get like a quick check-in and see if everyone is able to, not walk through whatever obstacles they placed. So the house, or there are rocks there. You could technically place like an empty roof and make it so that way you don't walk through that. Within, realism, it probably won't be the best example. All right. So over here, I can no longer walk into the house, and I'm getting the message in my console that we can't walk there. So up to date, everything's pretty good. All right, everything seems to be okay. So now we're gonna move on to tall grass encounters. All right, so our tall grass sorting layer should be on foreground, which it is, and the layer it's at is on tall grass. Reminder that layers in top right and sorting layer is part of the tile map renderer. And now we have to add the same components that we added to our solid objects layer, but we're going to add them a little bit differently. So first, we're going to add a tile map collider 2D, just like we did before, and a composite collider 2D. And then we're just going to go and do the exact same process again, check all the same boxes. So from here, tile map collider 2D used by composite, rigid body 2D, we're going to set that to static. And for the composite collider 2D, we're going to change the geometry type to polygons again. All right, and now we're going to go make sure that we are on the tall grass tile map in our hierarchy. We're going to go to the tile palette, switch back to background tiles, and then there should be some existing grass tiles for you to work with them. So you place those, and you'll notice some green lines around them. That should indicate that your colliders that we just added are working correctly. And now that we have our grass in place, we need to actually implement the functions for that in our player movement script again. So that when they're moving, it detects whether or not you're in grass. So we're going to go to our check for encounters. And we're just going to do to-do part 1. To-do part 2 involves integration with the combat tutorial. So we'll come back to that at the very, very end. So first, what we're going to do is actually fill out the function. So same structure as when we were checking for when we're colliding with like the house or the other solid objects. If physics 2D dot overlap circle transform position radius again using 0.1f for this. And this time the grass layer variable that we added earlier. And then we check if that is not equal to null. So if we are in grass, then we'll carry out the condition. And then from here, we'll just put another if. So if this is going to handle like essentially the encounters, because if we didn't have this, then you'd just be getting an encounter every single time that you walk into grass. And that would be annoying. So we're just going to set a range from 1 to 101, or you can do 1 to 11. We have 101, or the other example being 11, because it doesn't actually count like if the range is from 1 to 100. So if you had 1 to 2, it would just be 1 and 1. It just kind of subtracts 1 from whatever your second parameter is at the endpoint. And then I'm just going to have like a 30% chance encounter rate. So I'm going to have less than or equal to 30. And then after that, we'll have a debug log that says, you know, you encountered Pokemon. All right. We're eventually going to replace the debug log with a transition to the combat content. And now we need to add check for encounters in our move function. There it is. So here, the other to do, check for encounters, all we have to do is just add the check for encounters function, and we're good to go. All right. And then we'll hit save, and we'll go back to our Unity window, and then we can test stuff out there. My Unity is compiling scripts. But if yours is already working, you know, feel free to let me know if it works, if it doesn't work, and then we can try to figure out what's going on. I'm having that like full green bar, but then nothing's actually happening. All right, so now when we hit play, another green bar. But now as we walk in the grass, after you walk around a bit, you should get a console message saying that you encountered a Pokemon or whatever other message that you put. It shouldn't be happening every time unless you set it so that way happens every time. You can control the value by changing, you know, that 30 to some other number. And if we're all, you know, good here, then that's good. So just one more check-in. If something's not going well, just let me know. And then if not, we'll move on to adding in the NPC. All right, so now moving on to the NPC, we're just going to check that the NPC's sorting layer is on player and that the actual layer itself is on interactable, because we want to be able to interact with our NPC. And then now, just a quick little graphical detail, we're going to go edit, right next to file in the top left, project settings, which is towards the bottom. And then when we open up project settings, we're going to be in the graphics tab on the side. If you're not, just, you know, move there. And we're going to go to transparency sort mode, which is near the top. We're going to change from defaults to custom axis. And then we're going to change Y to 1 and Z to 0. So what this does is that it makes it so that way when the player and the NPC are at a position at which their sprites would overlap, the correct one is displayed on top, rather than just kind of like overwrite, you know, the bottom torso or the head of the NPC with the player's legs when the player's behind them or something like that. And if you want to test that, you can just kind of hit play, and then we'll walk behind the player, or sorry, behind the NPC, and walk in front of the NPC. So when we're here, they overlap, so you can walk through them right now because we haven't implemented the collisions yet, but when you are standing above, they're rendered properly, standing above or below. All right, so now we want to go to our NPC, and we're going to add a rigid body 2D, so that way we can actually collide with it. And we're going to change the body type from dynamic to kinematic. We changed the kinematic rather than static, you know, because we're in case we wanted the NPC to move in the future and things like that. And then we're also going to add a box collider 2D. So the rigid body 2D is for the physics, but the box collider 2D is what we're going to be looking at when we're actually colliding the player and the NPC. So within the box collider 2D, you should see a small green box around your player. If you hit edit collider, which is like the very first thing underneath the box collider 2D like name in your inspector, you can actually change the size of that box so that way it more accurately reflects your NPC's head instead of just colliding with some of the space above its head. All right, and we're going to go back to our scripts and we're going to check is walkable. We're going to make a slight change to that. So we're going to add on to the if statement. So right where it says solid objects layer, where we're checking if we're colliding with a solid objects layer, we're going to add the bitwise OR operator, which is kind of like just a straight up and down line. For me, it's right underneath backspace. And then we're going to add the name of whatever variable you put your interactable layer on. So mine is just named interactable layer. So we don't have to change too much, but everything's where it needs to be. And then now in our update function, we're going to add what we need to add so that way we can actually interact with our NPC. So right here, we're going to check if the input that we're getting, remember to capitalize the I, keep forgetting to do that. If the input we're getting is a Z, that's just the key that I've decided to go with, key code.c. Then we will interact, which is one of the functions that we have to fill out eventually. All right, so now we go to our NPC controller script, which is already partially completed. There's a debug log there for placeholder, but that's just so everything compiles and stuff like that. At the top, we need to add a dialog variable. So a variable of the dialog class, which was one of the pre-existing scripts that came with it, and then we'll just call it dialog with a UE. And then you can just change, the interaction function to just, some interaction or whatever message. So for example, if you wanted the message to say like, you should attend the procedural, so dungeon generation tutorial tomorrow, you could do that. All right, so we're just going to save our scripts. And sorry, before that, we got to fill out our interact function. So we're just going to copy this so I can type it correctly. I just type a lot. So for this, we're just going to check if the direction that we're facing for interact, which is a variable named facing direction, is a vector that. Okay, let's see. Sorry, roll back real quick. For the facing direction variable, we're just taking from the animator what directions that we're facing. So the move X and move Y are like 1 or -1. So like 1 being right, -1 being left, or up or down. So that's how we can tell where our player is facing. So we're just storing that in the facing direction variable. And then now, and we're going to have an interact position. So that's just, where on the grid we're looking at. And that'll be our transform position plus the facing direction. And then from here, we're just going to make a variable that's a collider that's going to essentially just check whether or not we're overlapping. The interact position is something that's on the interactable layer. And if it is, then we're going to have collider.getComponent interactable. And then there's a question mark there, dot interaction. So the question mark exists that way. If it returns null, then it doesn't mess everything up. So now that we've added that, I believe we should be able to walk up to our NPC, face them, press Z, and then get a console message. Okay, we've got some errors, no worries, we can fix that. So the first one says vector2 does not contain. There we go. I guess I didn't capitalize the I again. That's my bad. And the name interact layer does not exist in the current context. Helps if I spell interactable layer correctly. All right, now we should be good to go. No errors displayed. So when we hit play, we can just walk up to our NPC and then press Z. Oh, interesting. I forget to say. Oh, there it is again. I forgot to set the interactable layer. Probably should have done this all in one go. So within your player object, in the hierarchy, in your player movement script, make sure your solid objects layer is set to the solid objects layer. The grass layer is set to tall grass, and the interactable layer is set to interactable. And that should be good. So at this point, we should be able to move our player around, not walk into a house, walk through the grass, and occasionally detect a Pokemon, and walk up to our player, press Z, and then from there, we get a debug message for dialogue. And now that we've completed that, we're going to add just a very rudimentary dialogue system that actually makes a Pokemon style dialog box pop up instead of just having to use the console for everything. So you'll notice that there's within the canvas here, there's a dialog box with text that already exists. And it should be disabled, so you can't really see it right now, but we will be enabling it when we're actually writing the script out. And then the image for it is already attached and the font for it is already attached, so it should look okay once we get it going. So now within the Dialog Manager script, we're going to start filling that out so that way get everything that we need. So the first thing that we need to do is create variables for the dialog box, the text in the dialog box, and then the rate at which we want letters to appear. Because for this dialog box, the letters will be appearing like they do in Pokemon games, rather than just an entire text box showing up at once. They're going to show up letter by letter at an adjustable speed. So first thing that we're going to do is we're going to add, oh, I'm not typing. There you go. My cursor was not there. So we're going to add a game object variable called dialog box. Another one that is a text of text type, and we're just going to call that dialog text. And then we're going to have another one that's just an integer, so an int, and we'll just call that letters per second because that's the rate we're going to have the letters appear. Okay. So here we have just these first two lines, the awake and the part about instance, is just so that way we can get a reference to the dialog manager from other positions. So our NPC will be able to connect to our dialog system and grab that instance. Okay. So now we're going to fill out the show dialog to do. So from here, we're going to take the dialog box and we're going to set it active. So set active true. This will make the dialog box actually appear on the screen rather than be disabled where we are right now. All right. And then from here, we're going to uncomment the type dialog function by removing the slash and the star on top and bottom. And then we're going to go back to our show dialog and we're going to actually start coroutine type dialog dialog. Oops, helps if I spell it right. Dialog dot lines of 0. So what dialog dot lines of 0 means in this case is just the first item in the list of dialog lines. right? So if you remember from before, the dialogues class is just a list of dialogue lines, and because we're only implementing one for right now, we're just going to be using the first line, so that's of 0. And then now to fill out our type dialog function, first we're just going to set the dialog text in the actual box to just an empty string. We don't actually have anything yet. And then we're going to make a loop that takes each letter in the line that we're passing into the function, and then it adds it to the text. So we're going to have dialog text text plus equals letter, and then we're going to have yield return new wait 4 seconds. Oh, sorry. 1f divided by letters per second. So now that we've got that, we're going to have another yield return new wait 4 seconds. I know this is a lot of code right now, but I will go over it right afterwards. We should have 10f divided by letters per second. And then after that, we're going to set the dialog box to inactive. So dot set active false. So what we're doing in our type dialog function, we're going to take in a string that is the line of dialogue we're reading. We're going to have the dialog text that will be going in our dialog box to start with an empty string, and then we're going to letter by letter add the contents of that line to our dialog box. And then after 10 over letters per second, like amounts of time, we're going to set the box to inactive. So essentially what happens is talk to the player, dialog box shows up, the words show up over time, and then the box goes away afterwards. Just for the sake of time, this is a very simple dialog system. So there are some things that the player can do that you might not want them to do. For example, they are able to move while this dialog box is up. So if that's not something that you're looking for, I would suggest going over the previous week's tutorial because they cover game states. And although they don't explicitly cover like locking player movement, you will probably want to use that game states content that they cover. So that way you can make a state where your player can't move or something like that. That's just personally how I would go about doing that. All right. And now we go to the NPC controller, and then now we're going to replace the dialog, or sorry, the debug.log message with actual dialog. So we're going to have dialog manager dot instance. So we're grabbing that instance that we had preloaded in, so that way we can just kind of reference it now. Show dialog. And then we'll have that dialog variable that we have up here at the top passed into that. All right. So we're just going to save our scripts. And we're going to go over back to our Unity window. And then from here, we can go to the NPC. And within the inspector, if we just scroll down to the NPC controller script right here. Oh, that's weird. Let's try removing the NPC controller script, and then we'll just add it back. That's odd. Oh, it should have an input for dialogue, but it is not there. Manager. So we'll just try troubleshooting real quick. So we'll just hit play, and then we'll try to figure out what's going on. So from here, we can walk over to the NPC and request Z. So it's still running a placeholder. So it looks like it hasn't. Did I forget to change my code? Oh, okay. So I think what the issue is in this particular scenario is that because of the little hiccup that we had in the beginning, where we had to like close and reopen the new package because the original one wasn't working. The scripts that I've been working in for the non-player movement have been for the original skeleton and not this one. So I'm just going to open up these real quick and then just kind of copy paste over what I have. So that way we'll be up to date. So interactable and dialog should be the same, I believe. So we're going to open up Dialog Manager. Yeah, here it is. So we're just going to go to our existing Dialog Manager, and then we're just going to copy everything and paste it in over here. You shouldn't have to do this. But I have to. So Npc Controller, go to this Npc Controller, copy everything over here, and paste it over here, and we'll save that. And then we're just going to see what issues are up, and we'll figure them out. All right. So here, console. Let's see. Can I explicitly convert type string to Unity and text? Okay. So that is in our Dialog Manager script, and on line looks like 33. Okay. Within the Dialog Manager. Here it is. I forgot the dot text. That's what it is in the original. So dialog text with the capital T, the variable that we made at the very top, dot text. So the text portion of it is that's what we set to the empty string. That's what the issue was. So now in your Unity window over here, in the game controller object in the inspector, you should see the Dialog Manager script, and then that should have dialog box. It says no game object, no text, and the letters per second is 0. So we're just going to drag everything we need in. So from underneath canvas, we're just going to drag dialog box into the dialog box spot. We're going to drag text, the text spot, and then we can just set letters per second to something like 45. And then we'll be good. So now if we go to our NPC, within their NPC controller script in the inspector, there should be a little drop down for dialog. It should say lines, and then we can increase that to 1 for right now. So we'll just hit that, and then hit the drop down for that, and then you can type in your first dialog line. So then within that, you can just type in, you know, this is a dialog line, and you should be good to go. So now when we hit play in our scene, once everything works in, now we should be able to walk to our player, not walk through our player, and we press Z, we interact with them. A dialog box pops up, it reads out the dialog, and then goes away. So this is the dialog line, and then it goes away. If anyone has any issues, feel free to let me know. But other than that, I'm just going to wait for like a few seconds, and then we'll move on to our final piece, which is integration with the combat tutorial. All right, so now we're going to move on, last but not least, to our integration. Oh, issues with the same script linking issues. Can you go over that again? Let's see. Yeah, so if you opened up the original scripts from the first time that you had the skeleton, so like, you know, the one that didn't have the correct scenes and everything like that, by editing those scripts, you're actually editing it for the other skeletons. So that way in this, it shouldn't be changing. So what you want to do is you can close all those out, or you can just go to the scripts in the skeleton that we're using currently, and then just kind of open that up, and then just copy paste everything that you have in there, and that should fix the issue. So I'll just visually do the same thing. So from here, you'll notice at like the top on my Visual Studio, there's like 2 things for Dialog Manager. So the one over here on the right was the original one for the incorrect skeleton that I had accidentally been working on. So from there, I just Control A, Control C to everything, and went to the correct dialog manager, which I opened just by clicking, here, and then that should take you to the correct one, just by double clicking from the scripts folder, and then from there just Control A and then Control V-ing everything, so that way it's as what you've been working on. Yeah. And if that doesn't work out, then we can fix that too. But if you can get it working, just let me know. I'll just wait for a few seconds and then check in again on integration. Okay, so I'm going to take that as it's working. So as part of integration, we're going to go to our player movement script, the correct one this time. So if you want to double check that, just go to your scripts folder and then double click player movement. That should open the right one, guaranteed. And at the very, very top, we're going to add using Unity Engine .scene management. Right? Using Unity Engine .scene management with a dot between engine and scene, or sorry, period between engine and scene, and then capitalization on the U, E, S, and M of Unity Engine Screen Management. So at the very top, you should have 4 using lines now. And then now we're going to go to the debug log of check for encounters and fill out that. We're going to replace that with a scene transition so that we can actually get into a battle. So from there, we're going to do scene manager .load scene. And then the name of that scene is just going to be combat scene. That's just the name of it as part of the skeleton with a space between combat and scene, and then capital C, capital S. The issue with that, however, is if you were to run that right now, as your player moves, you're walking through the grass. Once you encounter a Pokemon, it sends you to the completed version of the battle scene. So that should be like a Charizard versus a Blastoise. But then from there, you don't really have a way back afterwards. So all we have to do is just go add another scene transition on that end. So we're going to go to, give me a second, my Unity is compiling scripts. We're going to go to combat scripts, which is the folder combat scripts in the little project tab, battle, and then battle system. So from here, we're just going to scroll down to the looks like execute moves function right here. And then right under within the if statement that says if is fainted, we're just going to replace exit scene with another scene transition. From there, scene manager .load scene. And then our scene name is Overworld scene with no space in between. And then just another thing that we're going to want to do is add the using Unity Engine .scene management at the top. If it's not already there, you want to make sure that it's there. So in total, we should have 5 using statements for the battle system. And we're going to compile scripts real quick. So we're just going to test this out, but there is going to be one small issue that we still have to fix, but that will become apparent after we test it out. So right now, technically everything works. It's just not exactly how we want it to work, which you will see in a moment. From here, I walk in the grass and I eventually, something's happening. Scene combat scene couldn't be loaded because I'm not going to add it to the build settings or the asset bundle. Oh, gotcha. Okay. So what we need to do is assets. Nope. File. Where is it? Edit. Give me a second. I'm trying to find where the build settings are. File, build settings. There it is. Thanks, Peter. File, build settings. And then from here, we're going to add open scenes. So we're going to uncheck that. Uncheck the sample scene right there. So then Pokemon scenes, overworld scene. So that should be there as a 0. And then we're going to go over to within Pokemon scenes, we're going to open our combat scene and then just save what you currently have. We're going to open that one up. And then from here, you should have a screen that looks just like this with 2 Bulbasaurs, text dialog without the UE. And then we're just going to hit add open scenes again. Again, this is in file, build settings, or you can use Control-Shift-B. And then once that's done, I believe we can exit out. Just going to double check that it's still there. Yeah, it's still there. Okay. So now we're going to open up the overworld scene again. And we're just going to try hitting play one more time. And that should fix what we need to fix. So now we walk. Yeah, we walk in the grass, and when we encounter Pokemon, it pulls up this Blastoise v Charizard battle. So we're just going to fight Hydro Pump, and then once Charizard faints, it does return us back to our overworld scene. However, there is an issue, and it's that we entered the battle from a position in the grass, and then we start over from wherever our player was started. So the issue that we need to fix is storing that player's positions. That way, once we return back to our scene, we return back in the correct location. All right, so back over here, we're going to go to our check for encounters function in the player movement script. And then right above our scene manager transition, we're going to use player prefs, which is just like a way for us to store variables that exist just kind of outside our scenes to store our player's position. So we're going to have player prefs, set, float, then we'll just call it X for the X position. And that'll be transform.position.x. And then we'll have the exact same thing 2 other times for Y and Z. So I'll name the variable 1. Okay, but if you use player prefs, can't the player just edit the player prefs file to effectively teleport across the map? That is a good point. Yeah, when I was implementing it, that was the player prefs was the general suggestion that I got. But I guess technically that you could edit your player prefs to teleport wherever you want. That is a slight issue. And then in order to preserve the direction that they're facing, we're going to have another variable. We'll just call this facing X. So this determines whether or not we're facing, left or right. And then we'll get Animator, get float, move X, which, if you recall from earlier, is the value that we use to determine what direction we're facing for the sake of animation. And then we'll just do another one, but that'll be facing Y, and we'll grab move Y instead. Here, move Y, and this will be called facing Y. And then we're going to use another player prefs value. So we're going to player prefs set float. And then we can use this to keep track of whether or not we've returned to the scenes. That way it doesn't continuously always load you in a certain position. For example, if you hit play and then you walk into the grass, you do the battle, you come back. But then from that point on, because your player prefs file is going to have those positions stored, we're in the start function, we're going to add something that puts the player in the correct position. But then if you don't have anything that kind of resets that, then you'll always start from where you left off, which could be something that you want to do. But if not, you can use this player prefs that I'm setting float that I'm naming just returned to 1. And then let's see, from here, we're going to go up to our start function. And we're just going to have it. What did I hit? I hit a. Oh, there we go. We're just going to have it called player is back. Sorry. If we've just returned So we're going to do get float just returned. If that's equal to 1, the value that we determined earlier, then we're going to run players back, and we're going to set just returned to 0. And then underneath is the players back function. So we're just going to fill that out. So transform dot position equals new vector 3 player fs dot get float x, and then just kind of repeat with commas for y and z. Here, comma, and then we'll go y, and then comma, and then with z. So that'll restore the player to where they were standing when they entered the battle. And then from here, we will set the animator to the correct direction as well. So we'll set move x to the variable that we stored, move x in, player prefs, get float, facing x, and then we'll have the exact same thing, but with move y and facing y. So we'll save. This player could also use sheet. All right. So now once our scripts are, and then enters a battle. So from there, we will ideally win the battle, and then we'll return to the exact same position. And then when we stop hitting play, we're back where we start. And then as we hit play again, to get around the cheat engine thing, would you have to encrypt the value somehow? I'm not super familiar with cheat engine, but maybe Peter or Richard would be able to help you out there. Let's see. There is a tutorial we did last quarter about. Oh, good enough. And you can check those out on our YouTube channel, or the ACM UCLA YouTube channel. So there should be a recording of that up there, if I remember correctly. Let's see. You could also think of it in like a positive light of maintaining the spirit of the earlier generation games, where things are incredibly glitchy. Like you can see with the Brilliant Diamond and Shining Pearl remakes, people have been doing a bunch of glitches with those, and we are making a Pokemon game. But other than that, I think that covers all the content that we wanted to cover for this tutorial. If anyone has any questions or any bug fixes, or sorry, not bug fixes, but any issues that we could potentially fix, just let me know and we'll try to work through it together. But other than that, thank you for attending. I suggest attending the advanced tutorial. Although it's called advanced, it's still helpful to know. And, there's a great walkthrough through it and everything like that. So hopefully you'll walk away with at least a better understanding than before. Yeah, no problem, Nate. I'm glad I was able to help out.